So for this video, I'll be going over problem 1 of the special worksheet 20. There are 9 parts to this problem, but before I get to that, I am going to cover IUPAC naming. So the goal of this naming system is to create an unambiguous relationship between the name and the structure of compound. So there are a few steps to follow through this naming process. So first, we have to find the longest carbon chain and name it. And let's just say you have 6 carbons in your longest carbon chain. So that base name would be hexane. So to number the main chain starting from the end closest to the substituent. This way, the highest priority functional group receives the lowest possible number. So you have to, if both ends are equal distant to the first substituent, you proceed until the first point of difference. If 2 points of difference are reached at the same time, then you would pick the one that is first alphabetically. And so third, name the substituents. So for kill groups, you replace the ane ending with ill. And so if you add a substituent with 1 carbon, that would be methane. But since it is substituent, you would change the ending and it would be a methyl group. So, and if there's multiples of the same substituents for straight alkyl chains, you gotta make sure you use prefixes such as di, tri, tetra, penta, etc. So it goes on from there. So, and the fourth step would be assign number to each of the substituents depending on the carbon to which it is bonded to. And last, complete the name by alphabetizing the substituents and separating numbers from each other by commas and from words by hyphens. So let's check out the first problem. So, how many carbons are in the main chain of this alkene? So if you look at this compound, the longest carbon chain is here, and it has 1, 2, 3, 4, 5, 6, 7 carbon atoms in the main chain. So if we look at back our 7 carbon atoms, that would be heptane is the best base name. So there is a side chain on the main carbon chain of this compound. It's right here. How many carbon atoms are in the side chain of this alkane? So this is just 1 carbon here. So 1 carbon is methane. Oh, well, it has 1 carbon atom in the side chain. And the side chain would be named methyl because you have to replace the ending. Oh, I messed up. Methyl. So which number carbon in the longest chain is bonded to the side chain? So you have to remember, number the main chain starting from the end closest to a substituent. So on this end, you are 1, 2, 3, 4, 5 carbons away from the main chain or from the side chain. On this end, you're 1, 2, 3 carbons away. So you would start from this end because it gives you you number the main chain starting from the end closest to substituent. So this end is closest to substituent, and that is the 3rd carbon that side chain is bonded to. So now that you have all the information to give you the IUPAC name for this compound, first, name of longest chain comes. Here are a few things that you should know when putting the name together. So first, the name of the longest chain comes last. Second, the name of the side chain comes before this. The two names are written as one continuous word. And third, the number of the carbon bonded to the side chain comes first, separated from the name by the hyphen. The correct IUPAC name for this compound is, so what I like to do for naming is I like to put a list together of everything I have. So we have the base name, which is heptane, and we have our methyl group at the third position, so it would be 3-methyl, and that's it. That's a pretty short list, but putting everything into a list will help you when you work with more complex structures. But for this, when you put it together, it's just going to be 3-methyl heptane. Pretty easy. Okay, so let's try another example. So for this, first we got to find the longest carbon chain and then name it. So if you look, the longest carbon chain is here. And that is 1, 2, 3, 4, 5, 6 carbons. So that is hexane is the base name. You could have also gone here. Does not matter. You would have the same answer. So now that you have your base name, you need to look at the substituents. So I'm just going to redraw this. So we have your longest carbon chain, and you have your 3 substituents. So now, next thing to do is to number the main chain starting from the end closest to a substituent. So you can see that both of these are 3 carbons away from the first substituent, but this has 2 methyl groups. So if both ends are equidistant to the first substituent, proceed until the first point of difference. This is two substituents versus 1. So you're going to start from this end. You're going 1, 2, 3, 4, 5, 6. So you have a methyl here, you have a methyl here, and you have an ethyl here. So you have a methyl at the third carbon, you have another methyl at the third carbon, and you have an ethyl at the fourth. And remember, if you have multiple of the same substituents, you use prefixes such as di, tri, tetra. So we have 2 methyls, so you're going to put di in front and when you put the name together. So now that we got a list together, let's name it. So the name of this compound is 4-ethyl 3,3-dimethyl hexane. So you look at this and you might think, wait, doesn't di come before ethyl? Well, yeah, but for the prefixes di, tri, tetra, any of those, you don't count those for alphabetizing. You count the methyl or the whatever the side chain is, not the prefixes. You don't count the prefixes in the naming for alphabetizing. So now let's go to the next example. So the longest carbon chain is here. And now that you found the longest carbon chain, you name it. So you have 1, 2, 3, 4, 5, 6, 7 carbons. So that is heptane. And you have 3 substituents. You number the main chain starting from the N closest to a substituent. So that would be here. So you have start 1, 2, 3, 4, 5, 6, 7. And you have a methyl here, and a methyl here. So you have a methyl, 2 methyls at the second carbon. And you have a methyl at the third carbon. So now we got our list together. You have multiple of the same substituent. There's 3 of them. So you're going to put the tri prefix in front of it in the name. So you put their name together, it's going to have 2, 2, 3 trimethyl heptane. That's the correct name for this compound. Last, so first, again, as always, find the longest carbon chain and name it. So the longest carbon chain is here. And it has 8 carbons, so octane is the base name. And then we have one substituent, and this is a very complex branch substituent. What you should look at is that it has 4 carbons, 1, 2, 3, 4. So it's a butyl. Oh, has a butyl side chain, but this is a tertiary carbon. It's bonded to 3 other carbons. So you'll put tert in front of it. So you have tert butyl. This is a tert butyl group. So, and that's at the 4th carbon. So 4 tert butyl. So the correct name for this would be 4 tert butyl octane.